Today, I'm going to be talking about the foundation for most of statistics, normal distribution, and standard deviation. And to make it fun and more relatable, I'm going to use bacon as the example, because who doesn't love bacon? Alright, so first of all, what is normal distribution? Simply put, normal distribution is a symmetric, bell-shaped curve that represents the distribution of many random variables. So distribution is just where the random variables are. Are they high values, low values, small, medium? It's important to note that the shape of the curve is symmetric. So there's a picture of it on this slide. If you look directly at the middle, so the highest point on the curve, look at all the things on the left. Look at the shape under the curve. And then if you look to the right, you'll see they're just mirror images of each other. This is important later. What's interesting too about normal distribution is that many items in nature, business, and psychology can all be normally distributed. Alright, so really, why is it useful? Why do we care? You're probably asking that at this point. Well, normal distribution is useful because you can take all sorts of data, you can have all these sets of data, and you can describe them with something called standard deviation. Standard deviation takes a set of data and it fits it to normal distribution. It arranges it in a way that it appears to be like that bell curve, the normal distribution curve. It's a standard that we can all agree on. We can make generalizations based on normal distribution and standard deviation. It's a way to compare data. Alright, so that still doesn't mean much until we have actual data and we can apply some of these concepts. So I'm going to use bacon for my example, just because it's comical and it's something that most people are familiar with. So say I'm collecting data on bacon lovers. I have a list of names, and I have the number of pieces of bacon that they ate in a month. So say Adam eats 24 pieces of bacon. David has 43. Casey eats 4. Brian eats 28. And so on and so on. If you're trying to describe the group, or the population as a whole, it's good to use normal distribution and standard deviation to talk about it. You can talk about how someone might fit into the group, or you can describe the whole group itself. So let's try it using even more basic statistics. You could say, hey, I've got a group of people who I've observed eating bacon for a month. On average, they eat 19 pieces of bacon a month. Alright, but how useful is that to say 19 pieces of bacon is the average consumption in a month for someone in this group? So you might tell that to a friend or relative, and they would say, oh, okay, so everyone in the group eats 19 pieces of bacon? Well, no, it's just the average. Some will eat more than that, and some will eat less than that, right? Well, of course, that's what an average is. So let's ask another question. How many pieces do most people eat? So I'm going to start with a histogram. Histograms is where normal distribution comes from. That curve really just represents tons and tons of bars, individual data points. This video won't be talking much about how to make a histogram, so we'll go through this part quickly. First, to make a histogram, calculate your range. So let's say in this group the range was 41. That means the person who ate the most and the person who ate the least amount of bacon, the difference was 41 pieces between them. Then, once you have your range, one good advice for making histograms is to take the number of variables, so in our example it's the number of people we observed eating bacon in a month, and take the square root, and then just round that to the closest whole number. This will be the number of bins, and a bin is just an area of numbers where we put our data. It's tinier ranges that define our data sets. So then you take your range, and you divide it by your number of bins to decide what values go in each bin. So in this example we had 6 bins, and the range is 41. So each bin will span about 6.83 values. So I said 7. So our first bin is 2 to 8. That means for every person that has between 2 and 8 pieces of bacon, they're going into that bin. Next is 9 to 15. So each bin represents 7 values. And just keep doing that until you go over your maximum amount. So start your values below your smallest value. In this case, someone just had 3 pieces of bacon. or 2 pieces, and make sure your bins go past the largest value. So I think in this scenario, someone had 43 pieces. So I have a bin that's just 43 plus. Then graph your data into a bar chart. So total up the number of data points in each bin and put it into a bar chart using Excel or some other similar software. I'm not going to go into too much detail about this point because I'm just trying to explain where normal distribution comes from. If you noticed in the last slide, the shape of those bars kind of look like our normal distribution, our bell curve. The idea is that over time, as you take more and more data points, more and more samples, you'll see a pattern arise. And if you see the picture on this slide, you'll notice that the bars are much smaller and smaller. Your bin ranges become smaller and smaller and smaller, till your lines begin to blur together and look more like a curve, like in the picture. Alright, so back to that question. How would you describe this group of people who eat bacon? You wouldn't just say the average is 19. Looking at this bar chart, you could say, let's pick the middle 3. So we could say most people have between 9 and 29 pieces of bacon. Makes sense. If you add up those 3 bars, you're going to get most of the people in the group. That is the basic concept of standard deviation. So standard deviation gets more specific. Think back to our bacon example. If you're trying to describe the group and you say, the average person in this group eats 19 pieces of bacon. We know that kind of describes the group, but we know things vary. People vary, data varies, everything varies. So yes, your average might be 19, but all your points you collected could be close, they could be far away. Where are most of them at? On average, how close are people really to the average? What is the spread of our data? The average distance from the average is standard deviation. On average, how far away are people from that average? It helps you understand the spread of your data. That's what standard deviation is. It tells you that distance from your average that most of your people will be at. Now, if you're not very familiar with algebra, haven't done math in a while, or just don't like it, the formula shown on this slide looks super intimidating. That's the formula for standard deviation. But we're going to go through it step by step, and you're going to understand what the formula means and why it makes perfect sense. Alright, so let's walk through this bad boy, step by step. So if you want to know where your data is in relation to your average, what do you want to know first? Well, you have to know your average. Average here is denoted by that U symbol. I created a box if you can see it. And inside the parentheses, on the right side, we have an average. That's what that U means. It's a Greek letter. Now that xi before it, that means your value. So you're looking at a value and you're saying, how far away from the average is it? What's the difference? So take your value and subtract the mean from it. The reason there's a little I below the x means you're just going to do this for every set of data. Every single point you're going to do this equation for, because you want to know about the whole group. That should make sense. Think about it. If we're trying to describe the whole data, why would we leave someone out? We're trying to describe the spread, so we need to include all our points to see where they're at. Now, the reason that's in parentheses, our value and the mean, and then we square that, is because we don't want it to be negative. If you have an average, things can be below it or above it. If they're below it, and you subtract the mean from them, it's going to be a negative number, which doesn't make sense if you're talking about distance. You can't say, oh, I'm -3 away. That's how far away I am. That just doesn't make sense. So we square it. But then you might say, well, squaring it is going to mess it up. And yeah, it will. It's going to make it a much larger number. That's why you see a square root over the entire equation. It fixes it later on. There's actually a name for this. The squared value you get, that really huge number, that's called your variation. So that's how much your value varies from the mean. Alright, so you'll find this difference between your values and your mean. You do that for every single value. See that giant sigma, that giant E looking thing? That means sum. There's an n on top because you're supposed to do it for all your values. That's why it says I equals 1 below it. That means start at your first value and go all the way to n, which is your ending value. That's all your values. So do that equation, your value minus the mean, for every single value. It makes sense. We care about all our values. We're not going to leave one out. Then you multiply that sum, so it'll be a big number. You multiply it by 1 over n. That's just a fancy way of saying divide that number by n, and n is the total number of variables, the total number of things we're looking at. So in my example, it's the total number of people who eat bacon in my example. Now, why would you divide by how many people you have? Because it's an average. We just calculated all the distances away that people are from the mean. Now we want to know on average how far away are people. So take your sum of all the differences and divide it by the number of variables that you have. That's going to be your average distance away. Take the square root of that, because we squared all our values, and you're left with standard deviation. Okay, great. We have our standard deviation. But what exactly does that mean? Well, like we were talking about earlier, on average, most people are an average distance away from the average. That makes sense. Sounds like you're saying the same word a lot. You kind of are. That's why we call it a standard deviation. So one average distance away from our average is one standard deviation. And we now know our standard deviation. So we can say most people are within one standard deviation of our average. But what does most people mean? So what does it mean? Well, this is when we go back to our bell curve, when we go back to standard deviation and normal distribution. Turns out, if you do this sort of thing often, look at the average distance away from average, you begin to see patterns emerge. And over time, these have been calculated. So in general, normal distribution says that 68%, so that's a decent majority, of your variables will be within one standard deviation of your mean. So on average, 68% of your people are the average distance away from your average. But of course you have more extreme people, more extreme values, that could be 2 or 3 standard deviations away. So for example, take your average distance from the average and go 2 average distances away in both directions, and you have 95% of your people. So it's an even bigger jump from your 68%. Go 3 average distances away, and you have 99% of your people. So almost everybody will be within 3 times your average distance from the average. And that makes sense. I mean, you're going to be close to the average distance away. The farther away you go from that mean, the more rare your data is, the more rare that value will be. If you think about it for our bacon example, it really makes sense. Our average was 19 pieces of bacon a month. Our standard deviation was 10 pieces. So using normal distribution, take 3 of your standard deviations, that's 30 pieces, and add it to your average. And also subtract it from your average, because you have people that are above average and people that are below average. And you have values that are above average and below average. So for our example, we would say 99% of all people eat between 0, because you can't go negative, really it'd be negative 10, and 50 pieces of bacon a month. And we know that based on our standard deviation. Now just a note here, I completely made up these numbers for bacon. They're probably much lower in real life, and I don't think the standard deviation would be as high as 10. But it's an easy way to think about it. So to make things more technical, fancy sounding if you will, there's another way we can talk about standard deviations. Because sometimes you don't want to explain the individual values for your standard deviations. You don't want to have to say, hey, for our bacon, a standard deviation was 10 pieces a month. Or for cups of water, you don't want to have to say Our standard deviation was 25 cups a month. You want to make it simple. Because everything relates back to normal distribution, people know that 68% of your values will be within one standard deviation of the mean. So we convert everything to just a very basic scale. We call one standard deviation a z-score of 1, plus or minus, depending on what direction you're going. So a z-score is simply put just the number of standard deviations from the mean, from your average. So if you're one standard deviation away in the positive direction, you have a z-score of 1. It's a way of describing where a certain piece of data is in your data set. Someone who likes a lot of bacon in our example might have a z-score of 2 or 3. So they are 2 or 3 times the average distance from the average away from the mean. What's great about normal distribution, like I mentioned earlier, is that all these percentages have already been figured out for you. You just have to look them up in something called a z-table, or you can use Excel or other programs to figure them out for you. So you can begin to compare data and understand percents of your population. Alright, so let's do another example. Something not food related. Say you're going to buy a new car and you know the exact type you want. You looked it up online and you know the average price for that car is $23,000 with a standard deviation of $500. Now in real life, I don't think you could find standard deviation of car prices. That'd be a little odd, but for this example, let's just say you do. Your local dealership has the car and they're selling it for $25,000. Offhand, you know, hey, $25,000? That's more expensive than $23,000. Why is this car more expensive than the average? And an even better question is, how much more expensive than the average? How often are dealerships going to be selling this car for more than the average? So also assume for this example, that average was the average price that dealerships were selling it for. So let's not get into the whole, what if you get ripped off discussion. So, to find a z-score, you simply take your value, subtract the mean from it. Does that seem familiar? Yeah, we're finding a distance away from the average. But then you divide that by your average distance away from the average, because we know our average distance away. So for this particular point, let's take how far it is from the average, and let's see how many standard deviations away from the average it is. What you're left with is your z-score, your basic number, usually between -3 and 3. So for our example, the car at our local dealership was $2,000 more than the average price of that car. So with a standard deviation of $500, this car has a z-score of 4. So we take that z-score and we look it up in a z-table or use some sort of program to figure it out. The answer it gives you is the percent of values less than that. So in our example, it was 999968. That means this local dealership is selling the car more expensive than 99.9968% of all other car dealerships. This place is selling it at a premium. So hopefully you find that kind of cool. And what's neat about it, to me at least, is that this stuff is real. So if you have a good sample and you know your standard deviation is a trustworthy number, and you know your average is a trustworthy number, you really can compare things like that and say, hey, this person eats more bacon than 80% of everybody. Or this car is cheaper than 60% of cars. It's just a useful way to compare things. So the way you would do this in Excel is you would type equals norm.dist, that stands for distribution. The whole thing is normal distribution, which is what this video has been about. So hopefully that makes sense to you at this point. The x, you type in your z-score, which we calculated moments ago. You say comma, then you type in the mean, which we also calculated, then type comma, the standard deviation, which you now know how to calculate, comma, then put true. Just always put true. True means it's going to take all the percent of values underneath your z-score. So all the values, it's going to sum them together and say this percent of values is below your z-score for your x. So for our bacon example, you could calculate the z-score of someone who eats 70 pieces of bacon. Then you could use this formula and say, oh wow, this person eats more bacon in a month than 98% of our population, or whatever it would be based on your numbers. You can also do the opposite. So instead of finding out your z-score and then saying, I'm above this percent of the population or below this percent, you can do the opposite. You can say, for example, hey, I like running. I want to run the 100-meter. And I want to be faster than 80% of high schoolers or college kids. You can find the average time and then the standard deviation. And then using the inverse formula, you can say, oh, if I want to be faster than 75% of these people, I have to have a time that's this many standard deviations away. So in Excel, you would say equals norm, but then instead of dist for distribution, you'd say .inv for inverse. So this is where you take a percent, which is a probability, and then you get your z-score from it. So you do probability, comma, the mean of your value, comma, the standard deviation of your value. And it will give you the z-score you need to have that many percent of people or values below your z-score. I'll end it on this. This video has been a very basic introduction to normal distribution and standard deviation. But if you understand the concepts I have taught, you'll have a good feel for what standard deviation and normal distribution is useful for. But there's a lot of areas of interest and a lot of specific notes to keep in mind. One thing that comes up very commonly in statistics is a population versus a sample. All the previous information I gave you has been assuming you have data on the entire population. So for our bacon example, we live in a world of just 30 people. If your information is only a sample, our equations and results will vary slightly. So instead of a z-score, you'd calculate a t-score. Averages are also calculated using one less than the total variables in the denominator. Another good rule of thumb is to have a good sample. So to have a sample and be able to relate it to the entire population, you need at least 30 points of data. That's a hard, fast rule that's followed a lot in statistics. Thank you so much for taking the time to watch this video. I hope you learned something from it. Good luck with all your future endeavors whenever you're using statistics or normal distribution. Hopefully you can apply them in a way that makes sense now.